Okay, good morning or good afternoon, everyone. Welcome to APNIC eLearning web class. This is the third session that we're doing for today, our eLearning Wednesday. The topic that we are going to cover is about DNS security. So coming into this class, I would assume that somehow you know how DNS works, you know the importance of DNS. I don't necessarily require you to have like some understanding on managing a DNS server, but how to use it is very important, which everybody does, right? Everybody uses DNS. So we'll look at the importance of DNS as an infrastructure, as a network service, and what can we do to protect it from people who wanted to use the DNS to send some attacks. So just a bit of housekeeping before we go on to that. Today is the 19th of March in 2014. It's 2:30 in the afternoon from Brisbane in Australia. I'm also going to introduce myself. We'll be together for the next hour. My name is Cheryl Hermoso. I work for APNIC. I work as a training officer, so I'm part of the training team who conducts face-to-face trainings, workshops, e-learning sessions such as this to the members of the internet community. So we feel that it's our responsibility to educate the internet community, our members and non-members alike. So we cover topics that are internet related, such as internet resource management, DNS, DNSSEC, IPv6, routing, BGP, and network security. Now this class specifically runs for 1 hour, and at the end of the session I would be asking you to fill in a survey just to get your feedback on the quality of this session, and if you have any other things to add. Maybe you want certain topics to be covered in the future, maybe we had some issues with audio video throughout the session, things like that, so that we have an idea of what we can improve on. So this is what we are planning to cover. We'll have a very brief overview, a review basically of how DNS works, because it will be our foundation to look at where the problems are coming from, or where are the different vulnerabilities with DNS. Where do you have to look, or where do you have to protect your system? Okay, then we'll look at slowly building up and adding security measures into it. Of course, the first part is securing the name servers. Okay, we'll have some items there on how you can protect your name servers. Okay, and the system that is running. After that, we'll look at two of the most popular ways to implement security protocols. These are transaction signatures, TSIG, and DNS security extensions, or DNSSEC. So these two are very important. There's a wide and a variety of documents that discusses these two in the internet community. They are asking us to implement DNSSEC. And why is that? Because of all the vulnerabilities, because of all the exploits that are happening nowadays. We will also look at DNSSEC more intently. So we'll look at the new resource records. We will look at what they are used for. How do we do the signing? How do we actually implement DNSSEC? What are the necessary files? What are the necessary outputs? So I don't think the 1 hour session that we have is enough for us to cover these, everything, especially DNSSEC. It might take us half a day just to cover all of this, but we will try our very best to give you the basics so that you can, you already have like a foundation to look more into DNSSEC. All right, so that's the plan. Hopefully we can maximize the 1 hour session that we have to cover these things. So to begin with, I'd like to just go through the process of how DNS works. This is just an overview, and we will look at the different parts or the different resolvers, the different types or functions of DNS as we go through as well. So how do you query, okay, for a domain? DNS, as you know, is the domain name system. Its primary function is to map IP addresses to domain names and vice versa. Of course, there are a lot of other things that you can query, things like the email addresses, or things like the mail servers, many different things. But at its base function or core function is to map names and numbers. So you have a resolver. The resolver is essentially your machine. Okay, your operating systems have this resolving function. It goes through a server. Okay, this is your DNS server that you set up. It's also called a recursive server. Why? Because it will act in your behalf to do the recursion. It will do the querying or asking for your question. And then it also acts as a caching server because every reply, every response that it gets are saved in a cache. And if there are others who would ask for the same question for a specific amount of time, it will be taken from the cache and not from the actual server that is authoritative to give that. Okay, so we have a recursive server. We also have an authoritative server. So this is how the query works. I will ask for a domain, in this case apnic.net. It goes to the recursive server. Recursive server goes to the DNS hierarchy. First, it goes to the root, then to a top-level domain. Okay, it will ask for that, but the root doesn't know the answer, of course. Okay, why? Because it has already delegated its subdomains. Okay, think of it as a tree. Think of it as nodes. So subnodes, okay, are delegated to someone else. Someone else is hosting it. So in this case, we will have like just a glue record to show us where is the next server that I should ask. So it goes to the root server, goes to the GTLD server until it reaches the APNIC server, which is the authoritative for to give that specific answer. The answer goes back to the forwarding or the recursive server and back to the resolver. That's essentially how it works, right? So it's plain and simple. DNS is one of the earliest protocols that were out there. Okay, the main reason it was developed is because it was harder for us to remember numbers rather than names. So what goes on? What happens if you do these queries? You see that it uses a lot of I think you can say it. You can call it as components. Okay, it's distributed system. Okay, that's a basic feature of DNS. You don't just have one server. It's not a holistic thing. It's not just one DNS server that everybody connects to. They are distributed around the world. Okay, so where could be the problem? Okay, now there can be a problem on this side. So if you can see my arrow, this side is the same part that we've discussed in the previous slide, right? From a server or caching forwarder, it goes to someone that's authoritative. This is your authoritative servers. Actually, these are your authoritative servers, not just the master. And this is your DNS server. This is your machine that does the resolution, right? So this is what you've already discussed. But that alone, you can see there may be vulnerabilities. Okay, what about in this setup? This is for the authoritative server. In an authoritative server setup, you have one or more than one DNS servers giving or serving the same thing. In order to do that, you have a master-slave relationship. You have one master or primary server that updates all the other secondary servers. So that's the case. So any updates in the master goes to the slaves. Okay, someone can do dynamic updates to the master as well, goes to the slaves. Okay, the zone files, these are just, you can consider it as a text file, which you can update. It contains all the resource records, and they are residing in your master or slave servers. That is a typical DNS setup, right? So where could be the problem here? Everywhere. It's the simple answer here. Everywhere you can see that it is vulnerable. There are loopholes. Here, somebody can pretend to be a cache. Okay, here somebody can try and pollute your cache. This part is concerned about data. Okay, the contents or the resource records. Somebody can try to fool you to input wrong information in your cache or in the master, or somebody can pretend to be the authoritative server and give you again a wrong information. What about on the authoritative server? When you're doing the updates, I've told you before that master and slaves, primaries and secondaries are all serving the same thing, and therefore any updates in the master goes to the slaves, right? So what if someone pretends to be the master, or maybe someone pretends to be the slave just to get all the values or the zone files that contains my resource records. What if someone dynamically updates something but they are not authorized? They try to change the mapping, maybe change the IP address, but they're not exactly part of our network, and so what they're doing is pointing you to the wrong IP address. What if my zone file gets corrupted? So this part, we wanted to try to fix or to protect our server. The way the different servers, scattered servers, are communicating with each other. Something that you have to remember is if you have like a master-slave relationship, it doesn't necessarily have to be within the same network. Actually, that's not recommended. It has to be geographically separated. So one can be somewhere in the US, the other can be somewhere in Asia. So you see that difference. So you need to protect that. You need to know that you are contacting the same person or the same server, okay, even if it's halfway across the globe. So those are just some of these vulnerabilities. Now, one very important or one very common type of exploit that has happened over the past 5 years is what we call as DNS cache poisoning. Actually, this exploit has been discovered about 10 years ago, but not until about 5 years ago when it was popularly used, okay, as an exploit. So how does it happen? You already know how DNS works. This is the typical one. Goes to the root, goes to the name server, okay, authoritative name server. But your server, your DNS caching server here, receives a lot of queries every second, depending on how busy your data server is, right? So it receives a lot of queries, it forwards a lot of queries, and so it needs a query ID. This query ID will help him identify and match the query from the answer that comes back, and then forward that to the proper client. So that's how it works. It goes back, the query ID of the answer also has the same value as the query ID of the, the question or the query, and then that is forwarded. But what about if there is a malicious user? So in this case, we have this guy here who has a malicious intent, who wants to pretend to be the authoritative zone, okay, someone to replace this. This is the authorized one, but he wanted to act like him so that he can change the way that we view the internet or that website, so that he can redirect us to a wrong or a dodgy website. So I will reply, he will reply back to the DNS caching server with a list of query IDs. Okay, and some of that, one of that is obviously bound to match. What's more is if you are running an open resolver, meaning everybody can query your DNS server, everybody on the internet can ask you questions, then he can also send a query. So he has an idea of what query ID he received as an answer, and therefore he have a range of query IDs to play with. So his answer is obviously bound to match. Now, of course, this other one, the authoritative server, will still reply, but the problem there is, what if this arrives on the DNS caching server first? So now it's more of a race between them. So whichever arrives first will be accepted, and the one that arrives later will just be discarded. Why is that the case? Because if I'm the caching server, I have no idea of the responses that arrives to me, whether they're coming from the right source. All I know is it matched with my query ID, so I will accept wherever it came from. Okay, so that's how it works. So in this case, if this answer from this dodgy person arrives on our caching server first, then our cache has been poisoned. So we'll forward that answer to our client. Instead of forwarding our packets to 192.168.1.1, it is now communicating, sending packets to 192.168.1.99. See how it works? It's quite plain and simple, especially if, as I've said, this DNS caching server is open for everybody. So now, I'm not trying to frighten you about it, but this is something that has been used a lot over the past 5 years. Of course, there are ways in which you can combat this, and we will look at that as we move on here. Now, the very first thing that you need to do, okay, is take advantage of the security measures that are added on your server, on the software that they are using for DNS. There are many different DNS applications, DNS software that are available out there. Some of them are open source, some are proprietary. The most commonly used DNS software is, of course, DNS Bind. Bind is released by IAC, or the Internet Service Consortium. Now, well, this is not updated. Bind 9. I think it's not 9.9.6 or something. Okay, and then down should be 1 or 2 versions up already. But what you needed to understand here is you must run the most updated or the most recent versions of your DNS software. It doesn't mean that if I'm running 9.9.4 now and I also maybe later on there was a new release for 9.9.5, doesn't mean that I automatically have to update to 9.9.5. Okay, you'll have to check what sort of updates have been added. The best thing is if there is a security patch, then right away you need to add those patches. So in this case for Bind, if you see something with the -P1, -P2, those are security patches, and right away once it's released, you have to update that. Okay, but a lot of name server administrators, if they're running hundreds or even thousands of domains, it is quite hard for them to update to the latest versions. I've talked to people who are actually still running Bind 8. Okay, and Bind 9 has been around for what? More than 5 or maybe even 10 years. Okay, and that's because it's hard for them to upgrade to the newer versions of Bind because of the number of domains that they are hosting. But what I would suggest is if there's a security patch or update for your current version, okay, just make sure that you update to that right away. Okay. Another thing there is hiding the version. It doesn't really solve much, but what people don't know, or you want that extra step for them to find out your version, because if they know your version, it's very easy to find the possible loopholes or possible vulnerabilities for that. So it's just a very simple simple thing that you can add. Okay, you just need to add like one line in your configuration, and that's it for the rest of your name server lifetime. So why not add it as much as you can? Next is you have to restrict queries. I've told you about it in the previous slide. We said that you don't want to be running open resolvers. And what are open resolvers? These are DNS servers that answer queries from everyone on the internet. Okay, there are many commercial ones that are also available as open resolvers, but they are highly monitored. So if we have that capability to monitor when our service is maybe being exploited, then that's okay. But most of us don't have that resource. So as much as possible, close it up. Don't allow just everybody to access or query from your name server. Only restrict it to your clients. Okay, restrict it to your clients because they are the ones who are paying. If you're a service provider, okay, you offer this service to your clients because they are subscribing from your network. Okay, so how to do that? Add an allow query if you're using DNS Bind. If you're using other versions or other DNS software, there should be an equivalent command or equivalent configuration that does the same thing. Next is to prevent unauthorized zone transfers. Now this is something that we will also address when we talk about TSIG. What is zone transfer? We're talking about the primary and secondary servers here. Whenever you make updates on the primary, let's say you change or added a mapping, added a resource record, or maybe you change the IP address that's mapped to a certain domain. So these changes will be propagated to your slave or secondary servers. Now you don't want just anybody to be like that. So you limit who can make zone transfers from you, okay, or to your server, okay, by creating an access list. Okay, another way to go around that, of course, is to use TSIG. We're not using access list based on IP address, but we are using a key, okay, a symmetric key. Run bind with the least privilege using chroot. So you're jailing your bind process. So if anything happens with your bind, it doesn't affect any other service that are on your server. Randomizing source port. This answers the problem with cache poisoning in the previous slide. So just don't use the query source option on your name server. And of course, these three things are very important. One is secure the box. You can only be as secure as the server that is running this name server. Now, if you have an operating system that is updated, make sure to patch it. If you don't have any firewalls, add firewalls, okay, to have those limitations. If all your software are not updated, meaning there might be vulnerabilities already available for those current versions, then make sure to update them. Okay, things like that, simple things that you can add that you would normally do in any other server. And of course, TSIG and DNSSEC. So let's focus more now on TSIG, transaction signature. So this is for protecting messages coming from primary to secondary and vice versa. In short, we are protecting transactions. So we want to know that we are communicating, okay? We are sending messages or zone files and transferring these zone files only to authenticated parties, to people or to machines that we know. In this case, the primary going to the secondaries. How do we do that? We will have a key. This is a symmetric key. We will generate that key, and that key has to be shared. So we're talking about shared key here, symmetric key algorithm. This key has to be the same, has to be stored, has to be in the configuration on both your primary and your secondary. Okay? So anytime they ask or request for a zone transfer, okay, the key will be checked whether it is the same from your secondary to the primary before the actual exchange or transfer of zones will happen. Okay. So which ones are we protecting with TSIG? If you remember, I told you we tried to categorize or define the vulnerabilities in the very first, I think first or second slide. We said that we can categorize them as either server protection and data protection. So what are we protecting with TSIG? It's more on server protection. Any unauthorized updates that are going on between master and slaves, and also between your authoritative servers to the cache, then it can be protected by TSIG. This is an example of how it works. Now, if I am a secondary server, if there are any changes with my master, what happens? I would go to the master and request for the updated version. That is done using an AXFR query. I'm requesting for a zone transfer, AXFR. Okay, but before that happens, I will of course attach my key, attach my key to my query, to my question, and send that to my master. The master will double check whether I have the same key from the query and also what is in the configuration file of the master. If so, then the response will go that way, it will be accepted, it will be transferred, but if not, it will be ignored. That's essentially how TSIG works. So any type of server, whether it's master or slaves, any transaction that goes on between them will be protected by this key. So you have to exchange these keys out of band. If I have, let's say, 2 or 3 slave servers, I can set the same password, of course, to all of these slaves, but we don't normally want that. So you can set separate connections or separate keys for each of them. Okay, so maybe one set of key for master to slave 1, another set of key from master to slave 2, another set of key from master to slave 3. But of course, since this is about shared keys, as long as both parties are configured to use the same key, that's alright. So what I'm saying is you can use the same keys for all of them. Although, of course, I am not exactly recommending it if you do that. Now, how do you configure or how do you use TSIG? There is a command called DNSSEC keygen. So don't confuse this with DNSSEC, not yet. Okay? Just so happened that we'd rather just use the same key generator. Okay? So as your goal here is to come up with a key. You come up with a secret key. Okay? With TSIG, we're using symmetric key algorithm. So we have to specify what type of algorithm we're going to use. You have to specify the number of bits. The longer the number of bits, the better. Okay, you can stick with 8 bits, of course, but you don't want that. You want it to be as large as possible because the longer key, the longer number of bits in your key, okay, the longer time it takes exponentially to crack it down. So again, longer number of keys, and also make sure to change it every so often. Just create a plan when you will change these secret keys. So after this step, you also, one thing, you have to specify the name of the key. And I would suggest that you make it as descriptive as possible. So if it is a key for nameserver 1 and nameserver 2, you say that's NS1, NS2, TSIG key. As simple as that. But make sure that it's descriptive, especially if you have many of these transactions that you want to set up. If you're generating many keys, so it will be easier for you. Now, after you've generated the key, it has to be communicated between your master and slave. There are many ways to do this. This is out of band, meaning it is beyond DNS. You cannot do it within the DNS software. Okay, it has to be done outside. You can either copy that using a USB stick, you can use SSH and SCP to transfer that securely. It's all up to you. But it has to be transferred out of band. And then you configure your servers. So you open up named.conf if you're using DNS Spine, and then add these configurations. After you're done with that, as with all changes that you do, you need to double check. Okay, you need to know, you need to check whether, okay, it's actually working or it's not working. You can use dig transfer. So if it's not working, maybe you've set up your own machine, it's not it doesn't have the key, then it should result to fail. If not, then maybe you have done something wrong. So now, more specifically, this is what you will see in your TSIG configuration file. For TSIG, the changes will be added to named.conf, which is your configuration file. See here that you've added a few lines. One is the statement that defines what your key will be, the name of the key, the value of the key. This secret will contain the value of your key. The example here shows something very easy, but it should be a combination of numbers, letters, even characters that within one glance you shouldn't be able to memorize. Okay, so as to avoid any issue when someone suddenly saw your configuration file and then just try to remember. So no, make it when you do the generate command in the previous slide, so it will give you a better value for your secret. You have to specify a server, so this is another option. In this case, we're setting up TSIG with 10.33.50.35, which is our secondary server. Okay, for this server, what key are we going to use? So I've defined a key with this name, and this will be the values or properties of that key. So what I'm saying is I will use this key. For server, any transactions with a server will be using this key. And I only allow transfer for anyone that contains this key. So notice the difference. Earlier I said that you can restrict any transfers, and you do that by setting up the IP address. But IP address can be spoofed, and you just want extra protection. So it achieves the same thing, but instead of specifying the IP addresses, you now specify a key. And if the other party doesn't have the key or if you checked and it did not match with your key, then the transfer will not succeed. Okay? In the secondary, it's the same thing. Only difference that you will see there, of course, is this server has the IP address of your primary, and also on your zone, okay, you specify which are your masters, which is pretty typical. Okay, but the allow transfer, you put it in your primary, just like this, right? Now, you don't always have to add everything or dump everything in your configuration file. The easier to go about it is to add an include statement. Okay, so you still have the configurations in a separate file. Okay, it's more streamlined, it's easier for you to look, especially if you have many servers that again are configured to use TSIG. And then of course you need to test, dig at your server. For the domain that you're trying to do a zone transfer, you specify the key. Now this will give you a transfer succeeded because you have the key, you've specified the key. However, if you provided the wrong key, then the result will be transfer failed. Okay, something that you need to know is this. Note that TSIG is time sensitive, meaning if my primary server and my secondary server doesn't have the same value of time, or there's a difference of maybe a few minutes to 30 minutes, then TSIG will fail. So make sure that either they've set to use the same, they set to have like the same time, or they are using an NTP service, okay, and getting their time values from this same NTP server. All right. So TSIG is time sensitive. So if you are maybe troubleshooting something, one possible cause while your transfers are failing is because of this. So any questions with TSIG? So that's just a very brief run through on how you can set up TSIG. Again, it's very easy, right? So as soon as you get out of here, if you're managing a service or a name server, make sure that you have this. It's a very useful protection. Now, let's move on and discuss more about DNSSEC. So with TSIG, our main focus is server protection. With DNSSEC, our main focus is protecting data, protecting the values of the data. So going back to our example on cache poisoning, if I receive a resource record, okay, I now have a way of checking. I can verify whether it is coming from the right authoritative server. Okay, so it protects the integrity of my data or the resource record that I receive because there is a chain of trust. Now, if in TSIG we are using symmetric key algorithm, we have a shared key in between them. With DNSSEC, we are using digital signing, digital signatures. We are using asymmetric key cryptography. Okay, we have two sets of key. We use these keys to sign, okay, to create a digital signature that would tell us that this particular resource record is valid. Okay. Now, DNSSEC has a lot of, it's a framework. It consists of a lot of components. It introduces a lot of things to our DNS system. One of that is additional resource record types. And so it is important for you, if you want to understand this more, that you will read through the documents, the RFCs, the standards. So RFC 4033, 4034, and 4035 are the ones that tells us more or discusses more about the DNSSEC as a standard. Now, there are, as I've said, many resource record types that are introduced. Not sure if I have a better. Yep, let's look at this from here. What are resource record types? If you have a mapping of an IP address to a name, okay, that is an A record. Okay, if you're finding the IP address for a specific domain name, that's an A record. Okay, if it's the other way around, that's a pointer record. You have CNAME records, you have NS records for name server, you have MX records for mail servers. So there are many types depending on what type of data, okay, you are mapping. Now, I've only mentioned some of the more common ones. Okay, there are many other resource record types. With DNSSEC, we are introducing 4 more additional resource record types. Okay? Now, the first 3 here are related to public key cryptography, meaning it contains signatures, it contains keys, whereas the other one is used for internal consistency. Let's discuss one by one. RRSig. Okay, so we said that here we are creating signatures, right? We are signing the contents of our zone file. Okay, what is a zone file? It's just, you can think of it as just a text file. Sometimes it's a database, but it contains all your resource records, all your mappings. So we are going to sign these records to know that it is coming from us. So we have a key, we generate a key, we use this key to sign the resource records. And the signature will be contained in a resource record type known as RRSig. Okay, that contains the signature. Next, DNS key. So if we sign something, how do we now publish our public key? If you guys remember, public and private key asymmetric key cryptography, we have 2 sets of keys, right? We have a public key, we have a private key that is generated at the same time. Okay, you cannot find out the public key given the private key and vice versa. But if you encrypt a plain text using a private key, you can decrypt it using the public key, or vice versa. If you encrypt it using a public key, it can be decrypted using a private key. But what we want here is to verify, okay, to know that it's coming from the right DNS server, okay, using these keys. So we have to publish our public key because we are signing using our private key. Okay, I hope that you can follow this. So basically, I have a zone file. It contains my resource records. I will sign this. I will use my private key to sign. Okay, and then I will publish my public key so that everyone who requests for my resource record with a signature, they can now use my public key to decrypt, to know that if it's doable, then it came from the actual authoritative server. So these public key values or records are added in the DNS key resource record. Okay, there is another one called delegation signer. Now, during our query process, we said that it will be coming from the root, going to the top level domain, going to a sub-level domain until it reaches the authoritative server, right? So in our example on DNS cache poisoning, somebody can just pretty much pretend to be an authoritative server. Now, there is no chain. Okay, there's no way of checking that it followed through the DNS hierarchy. So if I am your parent, maybe I am .com. If you buy a domain for myself, then I will give it to you. Okay, I will have a delegation to you. I have like a record that glues any questions that are going to me, but should be redirected to yours. Okay, but there is no way of me checking that even I have a delegation to a specific IP address. How do I verify that it's actually you, right? So that is contained in the DS record. It's like a pointer. So I am the domain, maybe I am APNIC.net. Okay, I now sign everything. Using this signing process, it will generate a DS record for me. And I'll have to forward that DS record to my parent. So I'm telling my parent that, hey, this is the delegation signer. You have to add it in your configuration so as there is a pointer, okay, from you going to my server. Okay, so I know, I'm sure that when I forward delegations, it's going to the right authoritative server. Okay, that information is contained in the DS or delegation signer record. There is another resource record that's used for internal consistency. What do we mean by this? So we have a list of resource records. We have a 3A records, followed by a MX record, followed by a CNAME record. Okay. Now, if I was able to maybe hack into your system, into your Nameserver, and then I opened up your zone file and added one line, added a new resource record, I added maybe an NS record. So, how how do I know that it hasn't been compromised? Okay, we are going to sign, and we have an NSEC record that indicates the flow of the resource records in my zone file. In that way, since we are enumerating basically the resource records that's supposed to be there, we are also saying that anything that's not recorded in my NSEC record is non-existent. Okay, so I can say that these values, if they do a query, it's non-existent because it's not in my NSEC record. So those four are the resource records that are added on DNSSEC. Now, I told you that we will be using keys, right? We'll use public and private keys. We'll generate these keys and sign our records. Okay? Don't forget that. That's the basic thing. You sign that records, you publish your public key using these resource record types. Now, the thing is, what if I make changes on my zone file every day? So does that mean, because if I sign it, if I make changes, I have to sign it, and so it will generate a new DS record. So this record, as I've said, has to be forwarded to your parent, to the upper zone, upper domain. So does that mean that every time that you sign your current zone, you have to forward DS records to your parent? So that is too much work, both for yourself and for your parent server. So to answer or to solve that problem, we will be generating two sets of keys. Okay, they're both public and private key pairs, but one is called as the zone signing key, the other is called as the key signing key. Zone signing key is used to sign the resource record sets as normal. That's what we're going to use, and we publish that using the DNS key record. But we also have another set of key called key signing keys. Okay, so ZSK and KSK. KSK can have a longer lifetime because we are going to use it or change it maybe every year. For ZSK, we might want to update that or change that every month. So normally with ZSK, it has smaller values, maybe 1024 bits in the keys, whereas with key signing key, there has to be at least double, so 2048 bits, or maybe even more if you can handle it, if you can generate that fast with your server. Okay, so the goal here is essentially to split up, okay, what you're going to use to sign only the keys which generate your DS record, which you will forward to your parent, and what you will use to sign your resource record on a day-to-day basis every time you make changes. Okay, so the usual problem that we encounter with DNSSEC is how do you now roll over the keys? So it's a bit hard because you have to be aware of the timing parameters. As I've said, with zone signing key, it has to be updated maybe, or you have to generate or re-sign the zones every month. With key signing key, you have to do that every year. It's not a rule, but in best practice, that is the typical time frame that we use. So basically, just look into that after you've learned about how to generate your or sign your zones. That is the next step. Okay, rollover, key rollover. So I've just listed down here the steps that you will need to do. This is for DNS bind. For other DNS software, it should be pretty similar as well. Now, what are the steps involved when you're setting up a secure server? First, of course, you have to add something on your configuration file. So open up your named.conf and add DNSSEC enable, set it to yes. DNSSEC validation, set it to yes. So only those two lines. The next step is creating your key pairs. So notice here, we are using the same command. We are using DNSSEC keygen. Okay, but before, the algorithm that we used was symmetric key. Now we are using asymmetric key, RSA. So DSA, RSA, those are the possible values that you use, but by default it uses RSA and hash using SHA-1. Okay, we need generated our ZSK. We're using 1024 bits, and we have to specify the name of the zone for which we are generating the key. Next step, after you've done that, is to publish your public key. So you're not actually sharing, like in TSIG, we have to share the shared secret, okay, out of band, right? Here, since we're using public-private key pairs, you just need to publish your public key. And how do we do that? Going back here, we are going to use which key? We are going to use the DNS key, okay, to publish our public keys. After that, you can now sign your zone. You use your private keys to sign the zone, okay? And the public keys are, as I've said, already published using a certain resource record, okay? After you've done that, when you sign your zone, it will create a new zone file, okay? If you don't specify a file name, the one generated will have a dot signed, same name as the previous file, same zone file, but it will have a dot sign. And the size will be very different. Why is that? It now contains all your signatures. So if you open up your original zone file and the new zone file, you will see that it has added some values there, which are the keys or the hash values of the signed resource records. And then you update your configuration file to point to that and do some testing. Now, more specifically, how do we actually do this part? Okay, right? How do you sign your zone? There is a command called DNSSEC sign zone. So again, first step is you generate the keys, that's DNSSEC keygen. The next step is to sign the zone using DNSSEC sign zone and using the keys that you have generated in the previous command. So in this case, we are using this. Okay, this is the name of the generated key. Your output will be this, and then the zone file that you're going. This one is your domain name, and this one is the file containing your resource record, or this is basically your zone file. Okay, so once you have done the signing, you use that command. The output will be something with a dot sign extension, which is a lot bigger than your previous ones. Okay, everything is signed, but notice that some of them are not. Only a very limited few. Name servers or NS records are not signed, but all the others, including the DS records, are signed. However, any glue records, which is essentially pointing to another name server, okay, is also not signed. Okay, so as I've said, notice the file difference. The file size will be much bigger, maybe 10 times, maybe even more. It's much bigger than your original zone file. Okay, after you've done that, you of course need to test. Okay, how do you test? You can add an option called plus DNSSEC. The plus multi-line value here is only for aesthetic purposes, so that you don't have very long lines. So you see that it's formatted better, and you can see your values, your results better. So dig at your IP address of your DNS server and the domain which you have signed plus DNSSEC, and you will notice something. It of course will still give you the mapping that you want. In this case, the default resource record that we are looking for is what? An A record, an IP address for the domain champika.net, right? But there is another one. It's not very clear here, but you notice that there's another line, which is this, which is called an RRSIG. Okay, this is the signature that is associated with this record. By the way, when we sign the resource records, we don't sign it one by one. We sign it as groups. We have RR sets. So if you open up your resource records, your zone file, if you have, let's say, 10 records adjacent or next to each other that are all A records. Maybe after that you have 3 CNAME records. After that you have another set of 5 or 10 A records. So you sign each group separately. Okay, so one for the A records, another one for the CNAME records, another for the A records. You don't sign the whole thing, and you also don't sign each resource record individually. Okay, so basically when you do the testing, you'll notice that you will have the signature there. It's the RR-SIG, which is the signature of the RR set, not of the individual resource records. And it's bigger. If you see the message size, notice that value. You try to do a dig DNSSEC, it should be a lot bigger, again, because you have extra signatures that are added as part of the answer, right? So that's pretty much how you do it. So just as a recap of what we've covered, you have two things that we want you to focus on. Of course, you have basic things such as protecting your name servers, adding restrictions, adding ACLs, but two very important protocols that you may want to implement are TSIG and DNSSEC. There is a high, not demand, but in the community, it is encouraging everyone to implement DNSSEC for this particular reason. We've known why. We've discussed DNS cache poisoning. There are things that we cannot solve with DNSSEC, especially if you're doing an amplification attack. The amplification attack can actually aid, DNSSEC can actually aid amplification attack. Why is that? Notice when we do dig, when we asked for, when we do the query, our query is only a few kilobytes in size, whereas the response will be about 100, or maybe even it's around twice or even 3 or 4 times bigger than the answer. So let's just say it's 10 times bigger. If I do like a DOS attack, if I want to overwhelm a server, I can just do an amplification attack. Okay, I send many queries, small queries, but all the responses will be huge. Okay, and that is used to attack someone else's server. Okay, so that's DNS amplification. Over the past few years, you will see many different forms of attack that are directed to DNS. Why is that? DNS doesn't have any security in place. As I've said, it's one of the early protocols, so it doesn't have that. At the same time, DNS is very important in the internet itself. It's a network service. If someone can control your DNS server, then he can pretty much control the way that you access the internet. Okay? If you are, for some reason, connecting to maybe an open resolver, and someone was able to access that open resolver and change IP addresses, then you're actually accessing websites that may look very similar, oddly similar to the original website, but actually they are dodgy, and they are there, okay, as phishing or farming to get your information, to get your personal information, such as their financial information, credit card details, and all that, right? Just a few days ago, there was an incident with an open resolver, and as you know, Google, being one of the biggest search engines, biggest tech companies, they are also operating 8.8.8.8. So it's an open resolver. Okay. The attack is not exactly on DNS, it's more on PGP, but since it's an open resolver and many people are using it, our traffic is, or most of these people's traffic, were redirected to someone else. So that's one of the downsides of using an open resolver. That's why you want to be sure that the DNS server that you are using are trusted. Okay? Also make sure that you're not infected by any form of malware that may have somehow changed your DNS settings. So check whether your DNS settings are correct. It points to maybe your enterprise networks, domain name server, or your ISP's DNS server. Okay, so I think we will end the presentation there. Just a few things to help you understand what are the things that you can do to implement some protection for your DNS servers. So if you have any questions, this is the right time to post them. Otherwise, I'm also going to write the link to the survey so I can get feedback from everyone. So that's a link to the survey. I posted it on the chat. If you have no questions, you can actually have a copy of the slides. You can read through it. So if you have anything later on, you can get back to us, send us an email about it, and we'll be happy to help you out. Now, To get the copy of the slides, you'll need to first complete the survey, and then you'll be redirected to our FTP page where you can download them. All right? So, is there any question? Last time I'll ask this. No more questions from the audience? If not, I think I'm going to end that here. Thank you very much, everyone, for your time and for your participation. I hope that you learned something here that you can implement, whether it's for you personally with how you use DNS, or if you're an administrator, how you can protect your DNS server. Then I hope that you can do those measures that we have discussed. All right. Thank you very